Welcome to our LinkedIn Live. Thanks for joining, everyone. It's called Unpacking Gartner's 2024 Data Management Hype Cycle. So, as you all might be aware, LLMs are fast becoming commodities, and that underlying data, the substrate of intelligence, and is rapidly becoming the key differentiator for any company building any Gen AI apps. So, I'm Yukti, and I will be your host for today. So, let's jump right in. So, what is the hype around data management? Iceberg, real-time data vectors, drag, right? So we have Sanjeev, Mohan, and Madhukar, great experts, everything related to Gartner and data. We all have it here. So they do a tear down of the Gartner hype cycle and talk about the same real life use cases from enterprise AI to all other different kind of hype around vectors that is there in the market currently. So join the discussion with us. So take it away, Madhukar. Thanks everyone for joining.
All right. Thank you so much, Yukti. And I would immediately clarify that we are not experts, at least not me. We are just people with a lot of opinion. So, welcome, Sanjeev. It's
Thank
always
you.
great to talk to you because I know you and I talk quite often about what we each hear
Mm.
from different customers while we are out in the field. And of course, today we are talking about the hype cycle for data management that just came out from Gartner. And in fact, we'll share the link where people can just go in and download it from there too. But you worked at Gartner for a very long time. And I wanted to understand just some backstory. Like, when did the hype cycle start? Like, I know it's so popular that everybody wants to read it, that, the image is iconic about different things that are at the top or in the trough of disillusionment. But tell us a little bit about the backstory. How did it start? What was the thing behind it that most people don't know?
Yeah, thank you, Madhukar. It's such a pleasure, actually. I've never done a program like this where we are talking about hype cycle. Hype cycle has been around for almost 20 years. I would say there are three iconic Gartner documents. Number one, by far, is the Magic Quadrant. And then you've got market guides and you've got hype cycle. And then there are a bunch of other ones. Cool Vendors is another one. So the whole idea of hype cycle was that is there a way by which we can channel all this energy that is going into these new technologies that are coming up and try to map what is that life cycle of what happens uh, in the life cycle or in the product uh, uh, from end to end. Like, for example, we notice when new ideas come up, there's a lot of enthusiasm, and these ideas start peaking very quickly. But then we notice that when they peak, the initial excitement starts weaning off, and then the reality sets in. So then you see that, from this innovation spark or a trigger, we reach what Gartner calls the peak of inflated expectations, where everybody has a lot of expectations. Right now, we're living through Gen AI world, but before that, we've had crypto, we've had all kinds of technologies. And then when the reality comes in and we realize how hard it is to do something, then it very quickly descends into the trough of disillusionment. And then it's from there, that's where the real work happens, actually, because now the hype is off, but we're now working through all the kinks and trying to fix things before it goes into a slope of enlightenment. In fact, these are my own words, but now that, as an independent, I work with a lot of startups. I would say the slope of enlightenment is almost at the moment of reaching the product market fit. And that's when the slope of enlightenment happens. And then you get to the plateau of productivity. That, to me, is when companies start understanding how to scale it.
Yeah.
Now, interestingly, by the way, we've noticed that some things actually disappear before they reach plateau productivity because, like, an example that comes to my mind, some years ago, we were we were capturing ledger databases. They were obsolete before Plato, and they get dropped off. So that's why you see that curve.
So I have so many questions, Sanjeev, but let's start with a couple of hot takes. First one, of course, is do you think it is used often by companies to adopt technologies? And number two, do you think it actually helps you predict where a technology be in the next couple of years? And the two are interrelated. Like in your
Yeah,
experience, do people actually look at these and say, okay, I'm going to invest in this because now it's in a maturity phase or whatever is the term for that?
I don't think so. I frankly, some people may be disappointed in me saying that, but I really like the way you started this episode by saying that we are not experts, with people with opinions. The same is true for all analysts. It's a shot in the dark. Nobody really knows. Some technologies move fast, some don't, and some just drop off the hype cycle. I don't see none of my clients, and I've had literally hundreds of companies I've spoken to in my past few years that have said by looking at the dot on the hype cycle, I've decided to make an investment. By the way, the same is true. Although Magic Quadrant is far more influential, but I tell people that these are your baseline documents. They're just there to build an awareness of different technologies, products, vendors. But then you really need to do the hard work and find out what makes sense for you. So I've never seen anyone make a decision on what technologies to adopt based on hype cycle.
Yeah, in fact, I was thinking about it, Sanjeev, and I think you and I talked about it as well. Like in today's world, most of the technology, whether it's
Mm.
B2C or even B2B, is available to users right away. You can go
Yes.
and try out Snowflake, you can go try out Mongo, you can go try out SingleStore all on your own without talking to a human. So does it matter now that people look at hype cycle? To me, a lot of it is like astrology, which is good for entertainment, but
I love that.
maybe
Yeah.
also something to help you see the bigger picture and the bigger landscape. I think it's
Yeah.
very helpful there to understand, what are the other things, and you make your own opinions out of this. But I want to get straight to, we are in the thick of AI, we are in
Yeah.
year two. So the first and foremost question is the hype cycle comes out
Mm.
every once a year, but
Mhm.
I've seen the hype change week over week. Like
Yeah.
personally, I paid for Copilot, I paid for Perplexity, I paid for OpenAI. In fact, my wife would say I'd spend my entire salary just on AI tools these days. But
Yeah.
I keep changing because now Claude Sonnet 3.5 is so much better. So now I'm using that
Correct.
versus the other. Do you think that the hype cycle also needs to now be more than once a year? Do you think, or what, do you think you will come out with a hype cycle that could be,
Mm.
almost on a weekly or a monthly basis till we are still in this thick of
Yeah.
AI storm?
Yeah, it's such a great point. In fact, I keep thinking that these documents that come out once a year are a little bit backward looking. But most of the people I talk to, they don't want to be backward looking. They want to be looking ahead. You will only get competitive advantage if you're looking ahead, not on what's transpired in 1 year. So 1 year is woefully slow to have a hype cycle because I've said on some of my previous events, every 6 weeks I'm reinventing myself. And uh, so yeah, I don't see how can you have a hype cycle, not just for AI. I think we are going to see this rapid transformation of technology become the norm. AI is just the beginning. I think we're going to see this across the board. So yeah, having a document come out once a year is not good. It's not that useful.
Now that I'm thinking about it, what would be really cool is if you have a diagram like that
Yeah.
and it keeps changing in real time based on
Right.
people's responses and a bunch of other things. So imagine that graph, and you could say, show me what it looks like today versus change the date, and it shows you what it looked like yesterday. And
Correct.
that would be pretty cool. So,
Yes. Yeah.
getting to, the cadence of how often does this come out. One thing that has, of course, been in everybody's mind is vector databases.
Yeah.
And I'm looking at the image. Of course, last year, 2023, it was on the rise of what
Hmm.
is called the innovation trigger. And now in 2024, it's almost at the peak. Interestingly, it didn't exist in the year before, which is
Yeah.
2022. So, what does that tell you about both vector databases in 2022 and before, and where it is today? What have you been hearing from your conversations?
Yeah. So, why vector databases are literally zooming through this? By the way, there's a very interesting angle to the uh, graph database is a category that has been on hype cycle for years and years. And for the last five consecutive hype cycles from 2020 to 2024, it's been stuck in the trough of disillusionment. So it's not moving. Uh, it's there. I mean, it's extremely valuable. Vector databases, on the other hand, have moved really fast, and that's because for the first time, organizations now have an ability to do some decisioning, get some concrete information out of unstructured data. We've had NLP, natural language processing, for many years, but was never really that great till large language models came into existence. And so LLMs only became prominent since ChatGPT came and exploded on the scene. Although OpenAI was coming out with uh, their models for the last couple of years, but Transformers came out in 2017. That took a few years, and then OpenAI. So really, the reason why vector databases are so hot is because for the first time, I can now take maybe 10 years of my 10K filings or my customer contracts, my supplier documents, and I can say, uh, embedding model, go read these unstructured documents, extract the entities, turn them into embeddings, and store them in some place, and that place happens to be vector database. And not always. I mean, you could actually store it even on S3 if you want, but vector databases give you this user interface, and now I can do similarity searches on it. So it, that is unlocking all this value that companies had in unstructured data. All of a sudden, it's now available to me using natural language. So that's why we see vector databases are moving so fast. Uh, but we can talk more about it. I just want to pause here because I have some views about standalone vector databases versus vector capabilities. But let me pause here and
Yeah.
say,
So I think it was you who reminded me, Sanjeev, that 2017, when the paper came out from Google, attention is all you need. That's when, and not to hype single store, pun intended, but that's when single store added vectors to its database. So we have had vectors since 2017. In fact, we have had customers using us for semantic search in production since 2017. But what blew me away personally was 2023. That was last year, early around January, February, when suddenly we saw a bunch of vector only databases just crop up. And of course, I also heard about companies building their own vector databases or libraries. And a lot of that came in from the open source library from Meta or Facebook, which was FAISS, FAISS. And it was in memory. So it was extremely fast. But the thing that I always thought about was what is the total percentage of data in unstructured format in really large enterprises? And the general thinking there is, and I bought into this hype too, where if you go to very large banks and financial services, or other B2B companies, a lot of them will tell you that, hey, we use vector, or at least what we hear from in general in the social media and post is, oh, okay, let's just dump all our PDF documents and then we would use vectors to use semantic search. That is great if you are in real estate or if you're in healthcare, where there is a lot of unstructured data. But what really was an eye-opening conversation for me was when I was talking to a very large customer a few months ago, and they said, I've been following this vectors and vector databases, but guess what? 90% of my data is actually in structured, either sitting in columnar databases in data lake or a data lakehouse or a data warehouse, or I'm a transactional application, it could be an e-commerce or retail. So most of that is sitting in either in JSON or sitting in SQL. How is vectors going to help me? And now, in fact, you're telling me a lot of times I already have two or three databases. Now I need to add another one. So personally, I felt that the vector only databases, and of course, this is the hot take, was never going to be a category by itself, but I was wrong. It is. And I still see it in the hype cycle. But let's talk about that, just the vector only databases. How prevalent do you think it is when you talk to customers or other experts? And where do you see that future?
So, Madhukar, if you look at vector database's primary job is to store vector embedding. A vector embedding, and you know this inside out, is literally an array of floating point numbers. So it is not very difficult for any database vendor to have this support for a column type that can store an array of floating point numbers. It's actually quite simple. Now, the trick is not just in storage, it's also in indexing. Because how well you index and how much latency you can reduce for similarity searches is the crux of why these vector databases are doing really well. Now, and so we will always have some specialized databases. Then we will not be in a situation where a single multimodal database will meet everybody's needs. So there is a category called vector databases. But if we look into large enterprises, to your point, do I really need yet another database? Because I have to join this. Vector embedding by itself, sure, I have embeddings for my unstructured data, but it's only useful if I can take my data from CRM on my customer, data from an ERP on actual transactions, and merge it with my unstructured data's entities. That's when the magic happens. That you cannot do in a vector database because vector database is serving a very specialized use case. So I think right now vector databases are new and getting a lot of hot press, but eventually we will see that it's not a standalone capability, it is a feature of your overall database. And I see that that some vector databases will survive. Actually, if you look at it, they're only, like if you look at search, it's only elastic. And then there are a bunch of other ones. If you look at document databases, MongoDB is actually number one, and then there are a bunch of other ones, but much smaller. Look at Graph, it's Neo4j. So I think in vector databases, you will have one or two people who will survive, but the rest use cases will migrate into more of a multimodal database. That's my view. I don't know how you see it.
Yeah, absolutely. I feel like if you look at, then you know it better than anybody else, but if you look at the overall trend, just in the last 12 to 15 months, every single database now has support for vectors. So whether it is Postgres, whether it is Mongo, whether it is Snowflake, whether it is Databricks, you name it. Everybody now has vectors. So in many sense, it's kind of now table stakes. And when we think about even vectors, it's more about, okay, speed, that's great. You want to shave it off to a few milliseconds. So that's where all the advanced indexes or indices come in, like HNSW, PQ, IVF, a combination of both, and so on. But at the end of the day, what I see where it is headed, at least with AI, whether it's B2B or not, is we are moving away from just having what I would call a monochromatic text based response to high resolution data response. So, in my mind, a high resolution data response, let's take an example. This is a demo that we had built out. Is you are a customer support co-pilot, because that's the other thing that I see in a lot of enterprises. It's the most common use case, but they don't often would expose that AI application directly to the end users. They want some humans to use it because they want a human in the loop. Plus, you want to make sure that it is really grounded and aligned before you actually open it. So, in that use case, let's say a customer support rep, and we use it by the way, is using a co-pilot. You ask something about a specific customer issue that you get, but instead of just getting, something that is based off a semantic search, you're also getting live analytics, like how many other customers have reported this. Is there an incident going on, and what are the metrics related to that? What is the sentiment of overall other customers associated with it? So it helps you make better decisioning versus just taking, monochromatic data and really making it high res. So from that perspective, now we are really talking about, and that's two other topics I want to talk to you, Sanjeev, is advanced retrieval augmented generation, or RAG. And in that, what we typically see is in enterprises, you want to do both semantic search, but you also want to run SQL queries because, as we talked about, there's a bunch of data that's sitting in tables and sitting in a very structured format. And so, in that use case in advanced RAG, you cannot have multiple trips, one to your vector, then back to get the chunk, and then again to your SQL. And the second thing is, of course, you cannot have just rely on text to SQL. It is getting better, but still about 30% accuracy. So that's where I see a lot of companies combining their own SQL as function calling or as an agents along with RAG as well. So my personal take is you're exactly right. I think we are already over the hype of the vector only databases, and we will be seeing a lot more work around retrieval augmented generation, which leads me to my next question. Do you think retrieval augmented generation, or RAG, should be in the data management space at all? Because now there are certain companies and frameworks that offer it as a service.
Yeah, so RAG is interesting because my personal feeling is that RAG is an accidental architecture. I've never used that term before, but there's a reason why I'm saying that is because, like I said, LLMs exploded into the scene, but they were trained 18 months ago on generic data. So I needed to harness the power of this language that LLMs give me with my own data. So RAG came into presence. Now, what I'm hoping to see over the next year or so is that we will get better at fine-tuning the models. And if I can fine-tune it, then the need for RAG goes down a tad bit. However, there will always be, at least for now, a combination of RAG and a fine-tuned model, because even though I can fine-tune it, but I'm not continuously fine-tuning it. Maybe we'll get to that point where we've got some change data capture, streaming it, and directly fine-tuning my model. So, but till we reach that stage, I see that we're going to have RAG and the model they will coexist. Yes, RAG will become a SaaS. In fact, I think it's like Ravas. There are a bunch of companies that are doing that now. And it's also sort of getting abstracted by agents. When these agents are now doing, they're coming, there's this whole narrative I'm hearing these days. What has AI done for me lately? And AI is a hype, and AI is not, it's too expensive, it's not delivering the goods. I really feel that we are conflating a bunch of topics. Yes, AI is expensive. When you have to train a model, it can cost $100 million to train a model. But when we're not talking about training, we're talking about inference. And the inference cost is going down. In fact, just last week, I saw Salesforce announced agents. One of them is called Einstein SDR. Another one is called Einstein Sales Coach. So what it's doing really is, if I'm a salesperson and I'm using an assistant and I'm going to go make a sales call, I have the information about this prospect in my database. I just don't know what questions to ask. So the sales coach is taking this data from my CRM, from other sources, maybe emails have gone back and forth about a customer, and it is coaching me on how I can be more productive when I go and try to sell. And I think we're going to start seeing that, sales closure rates have gone up by 10, 20, 30%. We are already seeing customer success stories come out, plenty of them. So that's now an established use case. We hear about a lot of legal space, paralegal, because that's a very document heavy space. So Harvey and some assistants and agents are actually starting to make people more productive. So the RAG, whether it's self-hosted or it is hosted as a service, will not. It is an implementation detail that we need to consider. But in either case, RAG and a small language model that's fine-tuned is starting to show ROI, in my opinion.
Yeah, by the way, I love your comment on RAG being an accidental architecture. Last year, I also heard some people say it's a hack. But
Yeah.
I'll tell you what reminds me of a story that I heard about was when Google came out and they were talking to, I believe, Alta Vista, and they were
Mhm.
comparing the two, and they would do the same searches on Google and Alta Vista, and different results would come out. And very famously, the Alta Vista or this competitive search CEO said, "But you're not asking the right questions. You're not asking it the way that you should be asking."
Hmm.
And to me, that's like a really big thing, which goes back to RAG, where yesterday or day before yesterday, I was at another conference, and some CIO was talking about, "Oh, we have created this co-pilot for our company, but we see all the time that people are asking the wrong question. They're supposed to ask questions related to our company data, but they are asking about the Olympics. And we are trying to train our employees to say, don't do that, just do this." And to me, that kind of blows me away, is because those are the things that actually RAG is built for. You can use advanced RAG to not only ground it to your data, but put guardrails, to do semantic caching, to do governance, to do RBAC, which are all real use cases within enterprises. And I agree 100%, by the way, that it has to be more of a mixture of experts of LLMs along with, like you said, fine tuning. And as the open source models keeps getting better and better, you might want to choose certain open source models fine tuned to do something else. And I also believe fine tuning will get cheaper. Personally, what I'm trying to do is uh, create, just for fun, a clone of me with my knowledge and my style of speaking, or write.
Like Reid Hoffman. Didn't Reid Hoffman do that?
He did, yeah. And of course, he might have had a team, but I'm trying to do this at nights and over the evening. And what I found was today your fine tuning has gotten better, especially with LoRa or low adaptation ranking, because it's incremental. You're adding layers to an existing model, but it's still not there. It's still not there, and it is expensive. Like if I took a very large data set and ran it on, let's say, Replicate or Hugging Face, it still costs you a good amount of money if it's one model. But if you do it for several and you keep doing it because you want to keep updating it, it's an expensive thing. Whereas RAG, I feel most hopeful about when I look at Perplexity. They use real-time RAG, and you can hear even on Twitter, Arvind talk about it, that they have a mixture of experts of different large language models. But when they do the search, they look at their existing knowledge, and then they also look at real-time data and then give citations. To me, that is a really powerful validation of why advanced RAG, specifically in enterprises, should be at the peak of what I would say hype. But let's talk about the other pieces that you touched upon earlier. In fact, the one that I am really interested in is your background and expertise is in data fabric and data mesh. And from pure English perspective, for our audience, they may not know, it is a typical enterprise will have several different databases, right? And we are talking about thousands of employees or quote unquote customers. Some are data analysts, some are data engineers, some are developers, and some are business people. And they want to access different data sets. So how do you give them access to certain parts of data when your schema is changing, your data keeps changing? So data mesh and data fabric, the way I understand is a thin veneer where everybody is doing the queries, but it's agnostic to the underlying architecture, schema, and data. Is that right, or am I off?
So I think there are a bunch of topics that have come in here. So that layer of abstraction, that's not data mesh for sure. Data mesh is a concept. It's not an architecture. Data fabric is an architecture. All data mesh says is that the traditional way of doing data management is that you have a centralized team of data engineers. All the businesses make calls to this team and says, oh, I'm going to run this campaign. To run this campaign, I need you to go build me this extract of data. And then the data engineering team, they don't really understand the business language. So they just, they're amazing at Python or SQL, but they don't really know what does this clinical code mean and make some intelligent decisions from domain point of view. So that's one issue. The second issue is this data engineering team is always getting overwhelmed and by requests that are coming from every department in the organization. So what Data Mesh said was, we propose a decentralized, domain-driven approach where each department should own the data and the data transformation. Now, understandably, they are not experts at coding, so we will have sort of like a self-service infrastructure, something they call federated computational governance. So basically, it's an organizational model. That's what data mesh is. Data fabric, on the other hand, shifts to the technology side, and it says that businesses no longer want to get point solutions. So can we sort of pre-integrate a bunch of technologies and expose them through a semantic layer so the businesses can then, the decentralized business services can then use that semantic layer. So you see how data mesh and data fabric can very seamlessly go hand in hand, but because of this lack of understanding of what each one does, we pit them against each other.
I see.
the layer of abstraction that you're talking about, that is something which has literally caught on like hot cakes this year, is the table format. And with table format, I can now, for the first time, unbundle or disaggregate my compute engine from my data. So my data can reside anywhere. It can be in any format or multiple supported formats. If I put Iceberg on top, if I'm a data scientist and I like to use my notebook and use PySpark, or I like to use Pandas or RAID, if I'm a SQL engineer, or I like to use Python or a tool like Tableau or anything, as long as they support Iceberg, I can look at the same data and I can start doing my analytics on it. So that table format, by the way, ironically, in the hype cycle in 2024, there's only one new entry, and that entry is open table format.
Yeah, I'm looking at that. That's what I was going to ask. So, is the open table format same as Iceberg, or is it a bigger category where Iceberg is one of the open table format?
Yes. So I was actually joking on some show sometime back. Do you remember this show? And then the movie came out, Mamma Mia, where this girl goes looking for her dad. She doesn't know who her dad is. And then all of a sudden she goes, when you want to look for one dad, three of them show up.
Yeah,
So
I remember being dragged into a play with that storyline. So I have some vague memories.
yes.
Yes, please go on.
So like that, we went from no table format, this concept did not exist till a few years ago, to three of them now. And actually, there are more than three. There's Apache. Apache Iceberg, which came out of Netflix and with some contribution from Apple. There's Delta, which was created by Databricks. And then there's Hoodie, which was created by Uber. There are some other ones, by the way. There's something called Apache Pymon, which is very prevalent, I believe, in China. But these three, Iceberg, Hoodie, and Delta, are the three major ones. Lately, we see that the center of gravity has shifted towards Iceberg. So Iceberg is sort of becoming the de facto multi-vendor supported format. Delta, although is holding on to its own, because Databricks is quite a force in the analytics space, and also Databricks partners closely with Microsoft. Microsoft has something called Fabric. So going back to Fabric, which uses a object store called OneLake, which is based on Delta.
Got it. So why do you think just open table formats in general have certainly taken the front and center of whatever's happening in database? And I do want to come back to graph database in a bit, but let's talk about this, because even SingleStore, we now support Iceberg, and Snowflake is, of course, backing it. Databricks just bought Tabular, which supports Iceberg as well. But what is it that's driving it? Like, if we go one layer below,
Yeah.
is it because companies are looking for a universal format so that multiple or one interface could talk to multiple different kinds of data, or what is it that's driving it?
So, great question, by the way, and it's a little bit of a longer answer. So we give Snowflake a lot of credit for separation of compute and store. And yes, it was the first mainstream data warehouse that separated compute and store. And what that means basically is I could have one data warehouse. Instead of creating multiple data marts on top, I'd literally just spin up a compute cluster called virtual warehouse. And now marketing can have its own, sales can have its own, R&D, supply chain, manufacturing. But it's one storage with separation of compute and store. To give credit where it belongs, BigQuery was already doing that. Although BigQuery was a little bit limited to the Google space at that time, and so Snowflake was its first vendor-neutral cloud vendor neutral data warehouse. But what got missed out in this narrative was that, yes, you could have separate compute and pay for it separate from storage, but you still had to buy Snowflake. And so Snowflake cost has been traditionally known to be quite high. So you couldn't bring your own compute engine. You still had to use the vendor's compute engine, or they were separated. So the first thing that an open table format did was unbundling of your analytical engine from your compute, which meant was that now I could bring data from, let's say, single store or some operational database into a cheap object store, because we know object stores like S3, Azure Data Lake, storage, Google Cloud, uh, GCS,
Mhm.
cloud storage, they're very cheap and highly durable. So if I can bring my data into a highly durable and cheap object store, why can I not use Apache Spark or Pandas or Flink or something else? But you couldn't, because you could use it, but then it was a point to point. Now, what Iceberg did was it said that we will give you a common interface onto these underlying files in object store or even in a database, so you could bring any engine. That's one. The second, so cost and flexibility of engine. So we've got two things happening. Third thing, SQL. So you can use SQL if you want. So you don't have to migrate your analytical store to some new language. But the fourth thing that also became really amazing is we finally got transactional capabilities on an object store. See, object stores are files. So if I have to say, let's say my address changed, how how in the world am I going to go change address in the Parquet file? So these files get appended, which means that there are all kinds of issues with locking of files, file management. What Iceberg and others do is they make it all look like a table. That's why it's called a table format. It's not a file format. That's Parquet. It's a table format. So now I get all the ACID transactions. So if I'm changing my address and my wife is also happens to be changing at the same time, we will not have a contention because it's consistent. So we got that ACID layer on top of files, and it's literally it's a metadata layer. It's not really changing the files itself. Behind the scenes, these files are still getting appended and renamed and compacted. All that is going on, but it is hidden from me. So I can treat Iceberg like I'm used to treating a table, and Iceberg is doing all this underneath management of files.
Yeah, that is very useful, Sanjeev. I always learn something when I talk to you. One thing that does come to mind is, and of course, again, not to just make it about single store, but we have been doing both columnar, row-based analytics, transactional with ACID across petabytes of data in a few milliseconds. And now, of course, with Iceberg, we have support for that, and you can run those again at millisecond speed. But one thing that did come to my mind while you were talking through this is when you have this kind of an architecture, transactional, and then your data lake, you're always moving data quite a lot, which is ETL. And literally, ETL, for those who don't know, is extract, transform, and load. You extract the data, you do some transformation, and then you load. So you're adding cost and you're also adding latency, plus data integrity issues and all that. So one thing that I always cringe when I hear, and candidly, we have used it too because everybody else was, is the term zero ETL.
Hmm.
And when you think about zero ETL, it's literally extract and load, and maybe
Yeah.
you do the transformation later on. So it's ELT, not ETL, but somebody else is doing that for you. So when people say zero ETL, I feel like people are missing out the true essence, that you don't still want to probably move all the data. You eventually, and I think that's where Iceberg is very optimistic, because if you have all of that data and now suddenly you can access it, and you can access it just like a transactional layer,
Mhm.
that to me is a true zero
Yeah.
ETL, not
Yeah.
what we keep hearing from the others. Would you?
Yes. Yeah, I would say so. In fact, zero ETL is zero EL. There's no T happening.
Right.
And and by the way, extract and load are the easy part. It's a transformation where the business logic comes in the picture. That's a hard part. And that's a vendor lock-in to some extent, because you may use a vendor product and then, write your transformation, thousands and thousands of transformation. Extract and load is if I know my source format and I know my target format, then they're not going to change that frequently. I can automate it. And so that's why zero EL is important. I have a view of where Iceberg can go, and I want to validate this with you. We haven't talked about this before, but what I'm now thinking is that uh, even for unstructured, like we've talked quite a bit about RAG today, if I have unstructured data and I point some embedding model to it, I create an embedding. Maybe that embedding, instead of storing it into a vector database, I can store it into a file on my object store, but then using Iceberg as a common layer of abstraction, I can then do pandas and say open a data frame. And so I'm just playing out this scenario where all of a sudden I can now say join data in Snowflake or in SingleStore with this embedding data, because they're all Iceberg tables. So for me, I'm just doing a table, I'm just doing a join of tables, but one table is pointing to embeddings on S3, and the other table is inside SingleStore. And now
Yeah.
I've got a SQL, and I'm getting the best of both worlds without moving the data anywhere.
Yeah, I think the ideal scenario, which is, by the way, where we are headed, is let's say you have huge amounts of data sitting in data lake or lake houses.
Right,
You
right.
take the ones that you want to convert to Iceberg, and you do
Mhm.
that. And now through single store, you have real time, and you have, again, analytics, vectors, keyword search, everything is open to you using just SQL. In fact, you can even mix and match it with real time data of data coming in through Kafka
Correct.
stream or something like that.
Yep.
But before we run out of time, Sanjeev, let's talk about actually two other things. One is, if you were to build your hype cycle today, what would you call in data management at the peak? Maybe one or two, or maybe a few that's in your mind based on what you hear in the industry.
So I would say peak of inflated AI governance.
AI governance.
Yes. And the reason I say this is because, by the way, you put me on the spot. So AI governance comes to my mind. And the reason is because we are talking about governing something that we don't even know. I would even put, I think, is it yesterday, this week is when California passed SB 1047, which is this compliance thing. I put it in peak of inflated expectation, because what we're trying to do is we're trying to regulate, govern something that we don't even know what it does and how it does it. And guess what? The moment we try to do it, it's going to change in 6 weeks, and we get back to ground zero. I'm not saying that these are not important. I'm saying they're very important, but most of companies I talk to are still trying to figure out what is that killer use case that I should be doing in Gen AI. So then, there's so Madhukar, how last year we were so gung-ho about Gen AI. We said 2023 is a year of experimentation. 2024 is when we go production. Well, we haven't gone production yet in majority of the cases. We're still experimenting.
Mhm.
So that's why if I were to put something on peak, I would put compliance and governance as my two things.
Yeah, that's really interesting because I hear a lot about not just governance but privacy, explainability,
Yeah.
RBAC, all of that, security, operational security, as well as privacy and data security and so on. In fact, just to plug a little bit about your comment about enterprises with AI in production, we are holding our second, what we call as the AI conference or AI centric conference at Chase in San Francisco on October 3rd. And we will have some customers like Six Sense and others, LiveRamp, talking about their production AI use cases.
Mhm.
So I'm really looking forward to that. And before I forget, Andy, maybe we can, for the audience, put the link for where people can go download that hype report. So if from Gartner, of course, you can just go to our single store LinkedIn page as well, and you will be able to get this link. But yeah, I highly encourage everybody to go through it, even if it's for, looking a little bit in the back, but just painting the bigger picture of where the rest of the enterprise is. But let's get to the graph databases, Sanjeev. What do
Yeah.
you feel about that, with specifically in context of AI?
So graph databases are extremely important. There's no question about it. The graph data model is very, very intuitive. Is the way you think of something. You know how, like, as consultants or engineer, we love to draw boxes and connect the lines. Instead of boxes, you've got nodes. But the way you think is a graph data model. What graph does really well is that relationships between entities is a first class citizen. They're directly known. Like, Madhukar works a single store. His title is this. He joined on this date. He commutes to work, or is local or remote. All that relationship, the properties are first class citizens, and that's a metadata. So it's now there have been a number of benchmarks that have been done that show that one way to reduce hallucinations and improve accuracy of models is through a knowledge graph.
I see.
So yeah, so I think knowledge graphs are very important. We talked earlier about advanced RAG, and in fact, we moved on to data fabric. So I didn't want to go back to AI topic, but I was just thinking that there are so many techniques. There is a raw prompt, which is we know it's not the best way. There's prompt with some in-context learning or chain of thought. There is knowledge graph. And then we go into RAG, fine-tuning, and training. So knowledge graph sits in between. And but the problem with a knowledge graph that I see is that although the model is very intuitive, the use of graph has lagged because you needed to learn some language like Cypher or Gremlin. Although literally a few months ago, this graph query language standard got production or ratified. So there is now an attempt to put a SQL layer on top of graph.
Yeah, in fact, that's where I was going towards. I do have one more question, but then I see that we'll be running out of time. But
Okay.
my question about graph databases in general is, at the end of the day, if I think at really the schema level, a graph is a relationship model, although it's
Hmm.
multiple layers of that relationship. Why not just capture that in a relational table with lookups? Like, what is
Yeah.
the extra advantage
Yeah.
I am getting when I'm using a graph RDF,
Right.
for example?
So the advantage you get is you don't have to do too many joins in a graph database. In a relation database, your relation database must be very advanced to do 40 joins, for example. You don't have to do that in graph. It's just inherent in the data model.
Got it. All right. So I know we are just 4 minutes away from closing out. Andy, are there any questions? I cannot see it on my screen here. But if not, then what I would ask Sanjeev, like parting thoughts, where do you, I know we are moving in a very fast track lane where things are changing extremely fast. But if there's one thing that you think would remain constant, like AI governance, for example, what would that be? What would your advice be to all business users and B2B enterprises?
So I have a very interesting thought, a parting thought I want to share. Recently, one of very well-known influencers in the industry and a good friend, he posted something, if I were to paraphrase, that said, if you fail at BI, you will fail at AI. So that got me thinking that, wow, it kind of makes sense. And I was like, wait, this is yet another modern data techie example of confusing correlation with causation. So yes, there's correlation between if you fail at BI, then you would probably fail at AI. But what is the cause? The cause is got nothing to do with BI. The cause is data management. So I want to close by saying that the root cause of your failure or success in AI is how well you manage your data. And that includes everything about data quality, having understanding of your data in a single source rather than siloed data in multiple copies, automation, performance, security, RBAC, ABAC. So that's how. And Madhukar, what do you think? I think it's really the data management that causes a BI project to fail, and hence will cause your AI to fail.
Yeah, absolutely, and very well said, Sanjeev. So I'll close off with that. I would say BI to me, at least, is rapidly evolving. Like even for me personally, I ask a bunch of questions every week to my team, and at the end of the day, it either goes to Tableau or it goes to another data source, or some of it is inside some other graph and across different application. And for me, we are headed towards a place where you will be able to ask conversational but get back high resolution data when you ask those questions, and then you can preserve it. So that obviates the need for a BI tool in my mind. And that's where I think the world is headed, where you can talk to your data and it really opens up that or democratizes that data to everybody. But it has to be grounded, it has to be safe, it has to be uh, you know secure and all of that too. So to me personally, I think that's where it is headed in terms of data management being the core. As we started off where we said data is now the substrate of intelligence, and the large language models will continue to become commodity. So how you manage your data for that intelligence is what's going to differentiate the companies. And personally, I'm very excited for that future. But thanks again, Sanjeev. It was, as always, great talking to you, and I always learn something.
My pleasure. Thank you so much for having me on this. Take
All
care.
right.